Welcome all of you. So as you can see, we are going to do a few important concepts which will be required for MCQs in your maths, ICSE maths. Okay, so let's quickly start with those concepts. Now here, very first that we have to know, many questions are asked on this, is median. Okay, what is a median? Now children are going for ICSE, they still don't know what is a median. So let us first see if this is a triangle. Okay, here is any triangle, acute, obtuse, it can be any triangle. Okay, if it is any triangle, this median is, what is the median? It is the line which connects one vertex to the midpoint of the other side. Now, median need not be perpendicular, okay? It need not be perpendicular over here. It only thing it has to do, it has to connect the vertex to the midpoint. This is it. So, any triangle will have three medians always, and medians are concurrent, okay? Medians are concurrent lines, that is they meet at a point. So here this is the third median. Okay, so every triangle will always have three medians starting from the three vertices. Okay, now these medians are, remember, if this is A, B, C, M, N and O, this part, let me take this as a G. This point, the point of intersection of the three medians is called the centroid. Okay, and this centroid is cuts the medians in a particular ratio. AG is to GM is equal to 2:1. This part is going to be 2, this part will be 1. Here the vertex side will always be the 2, the side of the triangle, that part will be a 1. This will be 1, this will be 2. Here also AG will be 2, this will be 1. So this is one thing you will always need in your sums, especially in the MCQs. So I thought I will tell you this. So this is one thing about median that you must know. Now let's come to the second thing, the second one. What is the second concept that you must understand? The second concept is that of incentre. Now ICSE badly needs this incentre. What is an incentre? Incentre is, if you have a triangle, you can't go for ICSE without knowing what is incentre, what is circumcentre, what is orthocentre. Okay, you can't go for the exam. Now incentre is, when you have incentre, this is, the incentre is nothing but the angular bisectors. Means if this is a 60-degree angle, it will make it 30 and 30 and connect to the opposite side. If this is a 40-degree, it will make 20 and 20. And if this one is whatever angle, it will divide it into two equal parts. That makes, so this point is called the incentre, where the angular bisectors meet. Where the angular bisectors meet, that point is called the incentre. Okay, when the angular bisectors meet here, that is called the incentre of the triangle. Okay. Now for the incentre, we have more things to understand. The incentre, if we draw a circle, that is if we inscribe a circle here, this part, okay, this part or this part of the angular bisectors, they make the radius of the circle here. This circle which has been made inside it is the inscribed circle. Okay, this is the inscribed circle. The circle has been inscribed and incentre is at equal distances from the incentre, this distance D, D, D. So incentre is at equal distances from the sides of the triangle, at equal distances from the sides. They can also use the word at the incenter is equidistant from the sides of the triangle. So they can make an MCQ out of these. Okay, they can even make a question out of this. Okay, so these are the few properties of the incenter. Let's see some other properties. Now comes the orthocenter. Orthocenter. What is orthocenter? Okay. Now in a triangle, if we have the altitudes meeting. Now what are altitudes? Altitudes can be the 90-degree lines from this vertex 90 degree to the side, from this vertex 90 degree to the side, and also 90 degree to the side connecting the vertex. Now it has nothing to do of bisecting the sides. It will not bisect, not necessarily. Of course it will bisect in some triangles, not in all triangles. So if you have like this one triangle like this, see here is your 90-degree line, here is it, and maybe here it is. Okay, so it does not bisect. It is only at 90 degrees to the side. Okay, if it is at 90 degrees to the side, then this point, again they are also concurrent, and the point where they meet is called the orthocenter. Okay, that is called the orthocenter. Now this is the orthocenter. Now we have to understand, for a right angled triangle, okay, you know what a right angled triangle is. Where does the orthocenter lie? Okay, if it is 90 degree here, this is the 90 degree line from that vertex to this line. So this is at 90 degree. Here is the 90 degree line from this vertex to this line. Two of the altitudes already done in this triangle. The third altitude will be this. Okay, so the meeting of the three altitudes, the point of meeting of the three altitudes is the 90 degree vertex itself. So if you have an orthocenter, okay, orthocenter of a right angle triangle will be the 90 degree vertex itself. Now let's talk about the orthocenter of an acute angle triangle. This is an acute angle triangle. Where does the orthocenter lie? The orthocenter lies at the inside the triangle, somewhere inside the triangle. Okay, this is also acute angle. But I will now draw one obtuse angled triangle. Okay, an obtuse angle triangle will be drawn. Now see what an obtuse angle triangle looks like here. Okay, one angle is obtuse. This makes it an obtuse angle triangle. Okay, here this is the 90 degree line. Okay, if you want to draw the 90 degree line for this, you will have to extend this side and then draw the 90 degree line here. From this vertex also you will have to extend it, and then you have to draw the 90 degree line here. So the point of intersection of the three altitudes, okay, here see I'll extend it, I'll extend this, and I will extend this also. Okay, and this will go, and when I extend this 90 degree line, that is this altitude, these were the three altitudes, they come and meet at a point outside the triangle. So for an obtuse angle triangle, the orthocenter lies outside the triangle. So for right angled triangle, it is at the 90 degree vertex. Okay, at the 90 degree vertex itself is the orthocenter. Acute angle triangle inside. Okay, inside the triangle. Obtuse angle triangle, it will lie outside the triangle. Okay, this is one very important point, because these things can be made into MCQs. Okay, so we talked about orthocenter, we talked about incenter, we talked about centroid and median. Now we'll be talking about, what's the next thing? We'll be talking about circumcenter. Okay, so what is circumcenter? What is circumcenter? Now circumcenter is also very important from your syllabus. Okay, if I have a triangle, okay, and then the circumcenter is the intersection of the perpendicular bisectors. It has nothing to do with the vertices. It is the perpendicular bisectors of the sides. Okay, this bisects. Here also this 90 degree also bisects also. Okay, and here also this is also concurrent. Okay, I have written concurrent before. So these parts are equal, these two parts are equal, these two parts are equal, these two parts are also equal, and these are all 90 degree. Now they might pass through the third vertex, they might not pass through the third vertex. Okay, there is no necessity, it just can pass through like this. Okay, say this is not passing. So there is no connection between the vertex and the perpendicular bisectors. Okay, and the point where they meet is the circumcenter. Circumcenter is at equal distances from the vertices, means from here to here. If I connect this point to this, okay, or if I connect this point to this, these three are going to be equal, and this distance you see from the circumcenter to the vertex, let me call it D. Here this is also D and this part is also D. This D is equal to the radius of the circumcircle. It is equal to the radius of the circumcircle. Before this distance was the distance from the incenter to the sides was equal to the radius of the incircle. Now circumcircle, what is circumcircle? This is circumscribing a triangle. So this becomes the radius, and this distance has to be equal because it is the, after all, radius. So radius of the circumcircle. So it is equidistant from the vertices. What you must remember is incenter equidistant from the sides, circumcenter equidistant from the circumcenter equidistant from the vertices. Now which is that triangle for which the median, I talked about the medians, yeah, I talked about the medians, the perpendicular bisectors, yes, the perpendicular bisectors of the sides, just now I talked about it, and the angular bisectors, yes, angular bisectors. Okay, now they are all the median, okay, perpendicular bisector, okay, and the angular bisector. They are all same. If this is the median, it is also the angular bisector and it is also the perpendicular bisector. Okay, which is that kind of triangle? That is an equilateral triangle. Okay, I can prove it also. This is 90, 90. Why? Because this is 60. Here is 60, equilateral triangle, right? So if I have drawn the angular bisector, supposing I have drawn the angular bisector, this is 30 and 30. Okay, then this is automatically 90. So you see it has become the perpendicular bisector because this is equal to this. Why is it equal to this? This part equal to this part? Because it is. Why is this part equal to this part? Because it is congruent. After all, these two triangles are congruent. Okay, you can prove it congruent by many methods. Okay, these two sides are equal, 90 degree, common side. There are many ways of proving it. Okay, two of the angles equal. So the median becomes the perpendicular bisector and the same thing becomes the angular bisector only for an equilateral triangle, not even from an isosceles triangle. Isosceles triangle, these two sides will be equal, this will be unequal. So isosceles triangle, all medians will not work like that. Okay, so that is it in this video. In my next video, I'll be coming up with few more very important points from similarity, from mensuration, okay, and also from so in my next video, I shall be coming up with many more important points which you keep on missing. So it will be there in that video, which will help you in your MCQs and it will also help you in the sums. Okay, so that's it today in this video. Whichever concept is still not clear for you, please write a comment for me and I shall try to solve your doubt. Thanks all of you. Please don't forget to subscribe if you have not subscribed the channel by now. Thanks all of you. Bye bye.